Assalamu alaikum dear students. We are discussing continuity of a function. Now today we are going to discuss the questions related to continuity. Now the question is here, we have to find the points of a discontinuity of f of x equals to 2x plus 3x less or equals to 2 and 2x minus 3x greater than 2. Now here if we consider the function f of x plus 3, its domain is x less or equals to 2. So if we consider the domain minus infinity to open interval 2, that is open interval minus infinity 2, clearly this function is defined in this 2x plus 3. So here 2x plus 3 is polynomial, which implies that this 2x plus 3 in a domain open interval minus infinity 2 is continuous. Similarly, if we consider this part of the function, that is 2x minus 3, where x is greater than 2 here, and consider the domain open interval to infinity, that is those points which are greater than 2. Clearly here this 2x plus minus 3 is polynomial. Polynomials are continuous at each and every point of r. In particular, this polynomial 2x minus 3, it is continuous in interval to infinity, which implies that this function, that is f of x, which is defined by 2x plus 3, x less or equals to 2, 2x minus 3, x is greater than 2, it is continuous at each and every point except 2. Now we will check its continuity at x equals to 2. Now for this we need to find the limits, that is left limit and right limit at x equals to 2. Now the left limit is x, limit x tends to minus 2. F of x is limit h tends to 0, f of 2 minus h. Now 2 minus h is point which is less than 2, and for the points which are less than or equals to 2, f of x is defined by 2x plus 3. So put x equals to 2 minus h in this, it is simply limit h tends to 0, 2 into 2 minus h plus 3. Now which is again a polynomial. So for polynomial, limit is simply by replacing h by 0, which is simply 4 plus 3, that is 7, which implies that left limit of this is 7 at x equals to 2. Similarly, right limit is limit x tends to 2 positive f of x, that is limit h tends to 0, f of 2 plus h. Now 2 plus h is the point which is greater than 2. So for this we need to put x equals to 2 plus h in 2x minus 3, because f of x is defined by 2x minus 3 for all the points which are greater than 2. So put here, we simply get 2 into 2 plus h minus 3, which is 1. So this means that at point x equals to 2, left limit is 7, right limit is 1. So left limit not equals to right limit. Here left limit is 7, right limit is 1. So left limit not equals to 1, which implies that limit x tends to 2, f of x does not exist at point x equals to 2. So when limit does not exist at point, we say that this is not continuous at x equals to 2, although it is continuous at each and every point except this point 2. So 2 is the only point of discontinuity of f. Now the second one is, we have to examine the continuity of f, where f of x is defined by mod x plus 3 if x less or equals to minus 3, minus 2x if minus 3 less than x less than 3, and 6x plus 2 if x greater or equals to 3. Now for all the points which are less or equals to minus 3, this f of x is defined by mod x plus 3. So if we consider the points which are less than minus 3, that is strict inequality here, f of x is defined by mod x plus 3, which is continuous because it is a combination, or it is a combination by algebra of continuous functions. Here mod x is continuous, 3 which is constant, it is continuous. So some function is continuous, which implies that if we consider the points, for all the points which are less than minus 3, f is continuous. So this f is continuous. Similarly, if we consider open interval -3 to 3, -3 to 3, that is for all the points which satisfies -3 less than x less than 3, f of x is defined by -2x. Again it is continuous because it is simply a polynomial. Similarly, if we consider the points which are here, for all the points which are greater or equals to 3, f of x is defined by 6x plus 2. But if we consider the points which are greater than 3, strict inequality, still the function is defined by 6x plus 2, which is again a polynomial. So this means that this function is continuous. So we are left with only 2 points, one -3 and +3. Now we will check the continuity of this f at these 2 points. Now at x equals to -3. Now the left limit of this is denoted by limit x tends to -3 minus, that is negative -3 minus, which is simply limit h tends to 0 -3 minus h. Now -3 minus h is the point which is less than -3. So for all the points which are less than -3, f of x is defined by mod x plus 3, that is limit h tends to 0 mod of -3 minus h plus 3, which is simply mod of -3 plus 3, which is 6. Now the right limit at -3 is denoted by -3 positive, f of x limit x tends to -3 positive, which is limit h tends to 0, f of -3 plus h. Now -3 plus h is the point which is greater than -3. Now for all the points which are greater than -3, f of x is defined by -2x. f of x is defined by -2x. So put -3 plus h in -2 of x, it is simply limit h tends to 0 -2 of -3 plus h, which is simply -2 into -3, that is 6, which implies that the limit exists at point x equals to -3, because left limit is 6, right limit is 6, so limit exists. Also the value of the function at -3. Now -3 we have to put x equals to -3 in mod x plus 3, that is simply 6, which implies that limit x tends to -3, f of x is simply f of -3. Hence f is continuous at x equals to -3. So this point x equals to -3 is also the point of continuity of this function. Now at x equals to 3, here limit x tends to 3 positive, f of x is limit h tends to 0, f of 3 plus h. Now 3 plus h is a point which is greater than 3. Now for all the points which are greater or equals to 3, f of x is defined by 6x plus 2. So we have to put x as 3 plus h, which is limit h tends to 0, 6 of 3 plus h plus 2, which is simply 20. Similarly, the left limit at this point x equals to 3 is limit x tends to 3 negative f of x, which is limit h tends to 0, 3 minus h. Now 3 minus h is the point which is less than 3, so we have to put this 3 minus h in -2x, because f of x is defined by -2x for all the points which are less than 3 and greater than -3, which is simply limit x tends to h tends to 0 -2 of 3 minus h, that is -6, which implies that at this point x equals to 3, right limit is 20, left limit is -6, so right limit not equals to left limit. Hence this function limit does not exist, so we can simply say that this point is the point of discontinuity of this function. So we have only one point of discontinuity of this function, that is x equals to 3, or in other words we can say that this function is continuous at each and every point of R except x equals to 3. So thank you.